year. So 1819, this is lesson 6. And if you'll write it just under it, you can put graph, and I'm just going to do ditto marks, piecewise functions. And you can just, you know, bring that down. You don't have to rewrite the whole words. Now, I'm going to try to do the pictures. I drew some stuff up there yesterday on the board. I'm going to try to do it over to the side. This will be scratch work. You may not necessarily want to write it in your notebook, so I'll be sure and tell you what I'm doing just for the camera, just for the video. Lesson 6, graph, piecewise. Okay, we're going to start with f of x. Now, if you haven't done lesson 5, it is going to be definitely new to you. 2x plus 2, given that x is greater than 1. And the second one is negative x, given that x is less than or equal to 1. So you've got 2 pieces of line. We're only doing linear. I don't have to write this down. But if I'm just graphing this line if I'm just saying I'm going to graph this line with slope y-intercept, and like in Algebra 1, no restrictions, kind of what we did in lesson 4, I guess, where the slope y-intercept is 2, slope is 2 over 1, and the line would look something like that. Now recognize that we only want that graph from 1 over, and then we'd have to talk about whether that is an open dot or closed dot. So I only need that piece. And this one, what is the slope of that? Y equals, if you have f of x or y equals negative x plus what? What's the y-intercept? 0. And then the slope is negative 1 over 1. And it would look something like this. Now, obviously, both of them together, it's not a function. I mean, you can have those 2 lines on graph paper, but notice that every point except, I think it's negative 1, has one value, but everything else, so it's not a function. Don't write this. Don't write this. Don't write this. Okay, you're just watching me. But I need the piece of it from here backwards. So the easiest way to do this is not graph them by slope y-intercept. I learned that very quickly, and I'm just going to leave that up there, but I normally would erase it, is to do it instead by t-tables. It's just easier because you can pick the points that you want. How many points do you need to graph a line? 2. So instead of using the y-intercept and the slope, we're going to just plot 2 points. So take your graph paper, one of your slips that I got, and when you do your classwork, you're going to put your name across here. And if you've already filled them out sideways, that's okay. But I'd rather it up here. If you did it this way, you'd still need to turn it this way and graph it. That's fine. Take your straight edge, and in all cases, your x and y axis just kind of needs to be centered. We found out last year that I was trying to find things that would make these easier to graph. I don't know if it's working with y'all, and we'll just see. I hope I say it a little bit better. They struggled with it a little bit, some of them last year. And it all comes down to an out-of-the-box concept of function. Where we're interested in this graph is at its, I guess I call them the overlapping points, the crossover points thing. And that's going to be the split of these two. Any of your boundary lines is going to be the split. Well, it's not part of the graph, so you show everything not part of the graph, either dotted or open dots. So we're going to take our straight edge and put a vertical dotted line down through positive 1. Now, in the end, you could erase it. That right there means it's not showing. It's just there to help us. So I would just prefer you just leave it because it's not affecting, it's not part of the answer. So let's go. When I glue it, I'm going to glue it kind of sideways. So let's go over here to the right, and let's do f of x is equal to 2x plus 2. Now, instead of in t-table form, I want you to be familiar with that f of x format. So let's do f of 1. Now, back up just a minute. Here's going to be the easiest question for you. Instead of saying, what is the domain of this function? I'm going to say to you, is the domain of this function all real numbers? Look at your x's. Is every x on the is every number on the x-axis going to have a y? Well, let's look at it. This is every number, not including one to the right, not including one to the right. So that gets all of those numbers. Now, what does this one do? It gets every x, including one, to the left. Is that every number on the, yes, so the domain is all real numbers. If we want to just talk about the range just for review, we will when we get the graph. That's a little harder sometimes when you're looking at it without the graph. Range is pretty easy. And lines, with the exception of that vertical line, which it doesn't have a y in it. If it doesn't have a y in it, it's not a function. A vertical line is not a function. All the x's, you know, if it's x equals 2, all the x's are 2. 2, 7, 2, 1. So you've got 2 in the domain, and then you've got infinite. Your range is all real numbers. So that's the one line. All other lines, horizontal, positive slope, negative slope, are functions, and they are all, with no restrictions, the domain is all real numbers. So we're interested in 1, even though it's not on this one, but we've got it. That's going to help us know what 1.0001 is going to do. It kind of gets us a feel for it. And then we need another number in the domain. You can pick any number bigger than 1. I could pick a decimal. I'm going to do this without a calculator. Probably on quiz, I will not let you use a graphing calculator. They will graph piecewise. It's a little bit time consuming, but I would rather just let you use the pink calculator. We're going to do arithmetic that's pretty easy. So I'm going to pick 2. Sometimes I might pick a different number. I'll show you why in just a minute. But I'm going to pick 2. 2 points make a line. So when x is 1, we're going to put the work. I'm going to put 2 times 1 plus 2, which is 4. And when x is 2, 2 times 2 plus 2 is 6. So let's go graph those for this one. So I'm going to put, when x is 1, I'm going to go up to 4. 1, 2, 3, 4. Now, 1 was not in my domain, so can this 1, this 4 here, be an open dot or closed dot? Now think about it. 1 is not in the domain of this one. It's in the domain of this one. So it's like this. 1, and it really won't matter what this number is because 1's not in the domain. We can't deal with this right now. It may be in the range, but it's not with this one. So I have to make it an open dot with that concept of x is greater than 1. So when you go to 4, put an open dot. And then I'm going to say something I had to say yesterday because they were struggling with it a little bit. A couple of them were. And then I'm going to go to 4. Let's see. No, I'm sorry. 2, and then go up to 6. 1, 2, 3, 4, 5, 6. Now, 4 is in my, 2 is in my domain. So 6 is going to be in my range, and I can make that a solid dot. Now, let me say this to everybody. If we had graphed this, like I did up here, with either the t-table or with slope-y-intercept, this is the whole line right here. If I were to trace that line up and down, but this doesn't say all real numbers. It just says x is greater than 1. So I can only look at the graph from 1 up. This back here would be dotted because it's not part of it. So I'm going to connect those two to the right. Your second function is f of x is equal to negative x. Now, obviously, I need to know what's going on at 1 because it is on this piece of the graph. And I need to pick something included in its domain. What would be the next easiest number? Now, if you pick negative 10, you got to graph it. So pick a number that's easy. What would be another number to pick? Tell me a number in that domain that would be easy to pick, an integer. Negative 1's great. There's even a better one. Negative 2's good. There's even a better one. And there's nothing wrong with those. We can graph them. What's the next integer over from 1? What about 0? Yeah, we can use 0. Now, 1 was not wrong. I'll even put it on there. Negative 1 is not wrong. Remember, I only need 2. So if I pick 1, I get, now, recognize that negative x means negative 1 times x. So I'm going to write negative 1 times 1. That's what that means, which is negative x, negative 1. Some people call it opposite of x. So the opposite of 1 was -1. These are going to be opposites. Now, the opposite of 0 is just 0. So you'd have -1 times 0, which is 0. And that's only the two I would do, but we can go ahead and do the others. F of 1 would be -1 times 1, which is -1. Okay, I've done something wrong. Oh, you said, oh, y'all said 2. That was what it was. -1 and -2. Because I'm thinking, what did I put right there? Okay, F of -2 would be -1 times -2, which is +2. And I'm going to put a 2 for emphasis, a positive for emphasis. And then -1 times -1 is +1. Any of those two will work, and I'll show you that they're all on it. I mean, I could do -1/2 if I wanted to, -2.7. So I'm going to do F of 1 was -1. And 1 is in the domain, so I know -1 is going to be in my range. F of 0 was 0, and 0 is in my domain, so I have a solid dot there. And then if you want to graph those others, -1 gave you +1. I'll just put a little dot there. And -2 gave me +2. And you can see that those line up. There's the infinite line for a domain of all real numbers, all the way across. But I only need it from 1 to the left. Now, that very well could have been on your Lesson 3 quiz. It could have very well been on your Lesson 5 classwork, because I could ask you, what is F of -2? What is F of 1? What is F of 0? So it really ties back to all of those lessons that we've done. So we know the domain is all real numbers. What's the range? I'll turn it sideways for you. What is the range? Well, let's go look at our y's. Now, I know there is a y at -1, and so there's an x that will give me that right here. Is there going to be a y of -2? Are any of these numbers used? So we know its y is starting at -1, right? Now, let's go up here. Now, there's no y of 4 here, but there's one up here. So see, a solid dot always overrides, because F of -1, -2, -3 of -4 was 4. So 4 may not be in the domain of range of this one, but it's in the range of that one. So the domain range is actually y is greater than or equal to -1. Katie. Oh, you're just stretching? Okay, I can't tell the difference sometimes.